In this video, we're going to go over two formulas for two very specific sums that we could have. The previous videos have been rules for how we can algebraically manipulate a sum to write it a different way. These are actually formulas that are going to give me the result of completing a sum or of evaluating a sum. For these formulas, it will be important that the initial index is 1. We would have to modify the formula because we would get a different result if we started with a different initial index. All right, this first one, you'll notice that the terms that I'm adding up are just C. There's no I in there. C here stands for constant. So I'm adding up a constant term. Now if I were to write that out, my index is going from 1, we count, all the way to n, whatever that ending index is. And regardless of what the index is, I'm always getting the same term. So when my index is 1, I have a C. When my index is 2, I have a second C. I'm getting a copy of C for each one of these indices. So I can see what I'm getting is just a whole bunch of copies of C. How many? Well, because I started at 1 and counted to n, that's n terms. So we're just getting n copies of C. As an example, if I had the sum as I goes from 1 to 1,000 of 3, that's just 1,000 copies of 3. It's 3 plus 3 plus 3 plus 3, 1,000 times. 1,000 copies of 3, that would give me 3,000. Okay. Now, that's where this formula is going to be particularly useful, when you have something where you don't want to have to do this one piece at a time. And once we've covered both of these formulas, we'll be able to start then using the rules together with the formulas to evaluate some sums that it would be really, really tedious to do one term at a time. All right. Now, the second formula we're looking at is if my index and my term match. So this would be 1, 2, 3. Again, we're going all the way to n. My index matches my term. So I'm just adding up the first n positive integers. Okay. Now, that's a little bit trickier. What I'm going to do is I'm actually going to work out an example first and then see if we can't generalize from that example. So let's say I was doing the sum as I goes from 1 to 100 of I. So I know that's going to be 1 plus 2 plus 3 plus 4 plus dot 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 plus 98 plus 99 plus 100. Okay, I don't want to do that by just starting here and adding the terms one at a time. That would take forever. But here's what I'm going to do. I'm going to take my initial term and my last term, and I'm going to add them together. And that's going to give me 101. And then I'm going to work my way in. So I started with the first term on the left. I'm going to move to the second term. And I'm going to come one term in over here. So instead of the last term, the next to last term. I'm going to add 2 plus 99. That's 101 as well. It's the same sum because I made this number 1 bigger and this number 1 smaller, and those changes canceled each other out. 3 plus 98. That's also 101. Each time I move to the next number here, I'm making it 1 bigger. Each time I move to the next number here, I'm making it 1 smaller. Those changes cancel out. So each pair that I'm getting adds to 101. How many pairs will I have? Well, if I have 100 numbers on my list, because I'm going from 1 to 100, if I'm pairing them up, I'm going to have half as many pairs. So I'm basically going to have 50 pairs. That's 100 divided by 2. And each of those pairs is going to give me 101. So this just becomes 50 times 101, and I can work that out pretty quickly. It's 5,050. Okay. Kind of cool. Okay. Now, in this particular example, you'll notice that we had an even number of terms, and with an even number of terms, we were getting a nice pairing. We had 50 pairs. Let's just suppose I was doing the sum as I goes from 1 to 7 of I, so that I've got an odd number of terms. So that would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Okay. Now if I do the same thing, 1 plus 7 is going to give me 8. 2 plus 6 is going to give me 8. 3 plus 5 is going to give me 8. Now 4 didn't have a partner. I had an odd number of terms, so I'm going to have a bunch of pairs and then one leftover term. That's like half of a pair, and that's actually half of 8. So I can say what I'm getting is I have 7 halves. That's 3 1/2, 3 pairs and 1/2 of a pair. 7 halves copies of 8. That's gonna, I can cancel that. That's just gonna be 28. Okay. So it basically works to say what I'm gonna get is a bunch of copies of whatever my first and my last term are. How many copies am I gonna get? The number of pairs I have, which is just the number of terms divided by 2. And if it divides in evenly, great, I've got an integer number of pairs. If it doesn't divide evenly by 2, that just means I had an odd number of terms, and that just means I'm going to have half of a pair. But that term that's in the middle, its value will actually be half of the sums that we're getting. So the rule is this. If we're adding up the sum as I goes from 1 to n of I, okay, it's going to be n over 2. That's the number of pairs that we'll get. We've got n numbers in our list. We have half as many pairs. Times 1 plus n. That's the sum of each pair. Where I pair them up this way, working from the outsides in, starting with the smallest number and the biggest number, then the next smallest, the next biggest, etc., etc., etc. You'll often see this written as n times n plus 1 over 2, but I like to think of it, when I'm trying to remember it so that I don't just have to memorize it, I like to think of it as it's the number of pairs times the sum that I get for the pair, which is just the sum of the first and the last piece. Okay. This particular sum is an example of what's called an arithmetic series, and that's what this entire section in the textbook is about. I'm just giving you this one because this is one that you're going to see an awful lot next semester in calculus. So I just wanted you to have a little bit of practice working with it. Let's just try one. Let's do the sum as I goes from 1 to 500 of I. Pause the video, work that out. Come back and we'll go through it together. All right, so if I want to evaluate this, we're going from 1 to 500. I do want to double check that we're starting with an initial index of 1, and we are. So I've got 500 numbers in my list of numbers that I'm adding up. I'm going to have half as many pairs. And I'm going to multiply that by the sum of each pair. And the sum of each pair is just 1 plus 500. It's the initial term, which is the smallest one, plus the last term, which is the biggest one. So that's 250 times 501. Okay, let's work that out. So I get 125,250. Okay. So I did have to do a little bit of arithmetic here, but that's a lot less tedious than actually adding up 500 numbers.